So we're given a situation where there's two blocks with mass M1 and M2 are pulled through a valley by an external force F. The center of the top block moves through a radius of curvature R. When the blocks are at the bottom of the valley, as shown in the figure, friction is able to prevent the top block from sliding with respect to the bottom block. There is negligible friction between the bottom block and the valley floor. At the bottom of the valley, both blocks are moving together to the right with speed v. So part A asks for us to determine the magnitude and direction of dp dt parallel for a system that includes both blocks at the instant when both blocks are at the bottom of the valley. So it's asking for dp dt parallel, which is equal to F net parallel. And the full equation for F net parallel would be force parallel plus the parallel force of the earth plus the parallel force of the valley. But the only force acting in the parallel direction would be the given force F. So we can say that the answer to this, the magnitude and direction, would be this times P. And P would give our direction to the right. So then for part B, it asks for us to determine the magnitude and direction of dp dt parallel for the top block at the instant when both blocks are at the bottom of the valley. And then it gives us a hint saying, choose your system to be the top block only, use the result from part A, and note that dv dt parallel is the same for all choices of system. So we're going to need an acceleration in this situation. So we're going to need parallel acceleration. And this will be equal to, we know that F equals ma. That's just an equation we know. So if we rearrange this, we'll have A parallel equals the force, which we saw for in part A, over M1 plus M2, because we have to count for both masses times the direction. We know this from part A. Okay, so the next step will be to find this. dp over dt, because we only want the top block, is equal to F net M2 in the parallel direction. And we know that F equals ma. In this case, since we only want M2, our M will be M2 times the A we found, the A parallel. And this will all be equal to M2 over M1 plus M2 times F in the P direction, the parallel direction. And all we did was plug in the things we just found with the acceleration and in part A. So then, part C, it says, determine the magnitude and direction of dp dt perpendicular for the top block at the instant when both blocks are at the bottom of the valley. So it wants us to find dp dt perpendicular. And we already know the equation for this. It's m times v squared over r in the n direction, because the n direction is the perpendicular direction. But we have to figure out which mass we're talking about. And since it's talking about the top block, we're going to use M2. And that is our answer for part C. So in part D, it says, find the magnitude F net on the top block at the instant when both blocks are at the bottom of the valley. So we know that F net is equal to dp, it's only talking about the top block, so dp dt M2, which equals dp dt M2 parallel plus dp dt M2 perpendicular. And then all we have to do is plug in what we found in part A and part B and part C. So we won't have m2 m1 plus m2 plus m2 v squared over r in the n direction. So this is giving our parallel direction, this is giving our perpendicular direction, but it asks for just the magnitude. So another way to write that would be to square both of these and then take the square root of the whole thing. We'd have m2 m1 plus m2 f squared this squared plus m2 v squared 4. All of this, square root of that, which is equal to the power 1/2. And that'll be an answer for part D. And then part E, it reads, at the bottom of the valley, determine the magnitude and direction of the perpendicular component of the force the bottom block exerts on the top block. So first we're going to write out that F net of M2 is equal to F earth plus F contact of M1. We know F net of M2 is equal to this. We already solved this. In direction, and we know that F of earth is going to be negative into G in the perpendicular direction. And it's negative because it's going away from N hat. Plus, what we're finding is the F contact force of M1 in the perpendicular direction. We rearrange all of this. We'll have that F contact M2 is equal to M2 E over R M2 G. And that's our answer for E. And then part F says, determine the magnitude and direction of the contact force from the top block on the bottom block. So we already know what we would need to find F contact of M1. So first we're going to figure that out. We're going to have M2 V squared over R plus M2 G in the N direction plus M2 M1 plus M2 And once again, these are things we've already solved for F contact M1. Then we know, according to Newton's third law, that contact forces are equal and opposite. This is Newton's third law.
Really? I was like, yeah, what's this?
Okay. So with that being said, you can find F contact of M2 because we know it's going to be equal, it's just going to be the opposite side of this. So F contact of M2 is equal to negative this, which would just be negative M2 V squared over R plus M minus M2 over M1 and that is our answer for the final part of this question.